Okay, I think we're going to get started. We've got a couple of people that are still waiting to get in, but we're going to go ahead and get started. So I'm Tammy Dickinson. I'm the Principal Assistant Director here at OSTP in the Energy and Environment Division. I want to welcome everybody, and I'm delighted that so many of you were able to come today to our event on space weather, understanding potential impacts, and building resilience. It doesn't seem like it, but just a little over a year ago was the first meeting of the Space Weather Operations, Research, and Mitigation Task Force, or SWARM. By the way, that was voted one of the coolest acronyms in the White House. Personally, I thought it should have been assigned to the pollinator work that we've been doing versus space weather, but you know. I'm happy to look around and see so many of our departments and agencies in the room. You've all worked diligently on this topic over the last year. And I know that myself and my two co-chairs, Louis Ussolini and Caitlin, who's stuck outside in the gate, appreciate all the effort that you put into this task. I'm also glad to see so many in the audience from academia and from the private sector. Over the last year, many of you have heard me talk repeatedly about space weather and the importance of a whole-of-community approach. Recognizing the value and importance of a collaborative approach to enhance our resilience and the security of our nation to space weather storms. We must address this issue as a partnership. And finally, a big thanks to my colleagues in the Executive Office of the President, particularly to the National Security Staff, to the Office of Management and Budget, and to the White House Military Office. Without your help, we wouldn't be where we are today. So we have a really packed agenda today and an all-star lineup, so I'm going to move right into the agenda. And first, it's my honor to introduce our first speaker, Dr. John Holdren. And as many of you know, Dr. Holdren is the Assistant to the President for Science and Technology and also the Director of the White House Office of Science and Technology Policy. And I must tell you that without Dr. Holdren's steady and consistent championship for space weather, we wouldn't have gotten to where we were today.
Well, thank you very much, Tammy, and let me add to her welcome, my welcome, on behalf of the President to all of you assembled here in this room for our event on coordinating efforts to enhance national preparedness for space weather events, and welcome as well to those who are watching the webcast of this event. I'm really delighted to have this opportunity to discuss this issue, which I know many, maybe most people in the United States don't realize is an issue. But it is important, it is a priority for this administration, and we absolutely need to ensure that our nation is appropriately prepared to respond to and recover from space weather events. So I really need to start, I think, probably not for folks in this room, but maybe for some watching on the web, with what we mean by space weather. Space weather, in a nutshell, is variations in the space environment, with those between the sun and the earth of particular relevance, obviously, to us. That means solar flares, coronal mass ejections, all leading to energetic solar particles and electromagnetic radiation, which reach the earth and its vicinity, and impact systems and technologies that are in orbit or on the surface of the Earth or in the atmosphere in between. And I think later in today's agenda you'll see some visuals of these phenomena, which are amazing visuals, by the way. If only space weather was not so disruptive, it would be wonderful to watch. There's much that we still don't understand about space weather. We do know that space weather events occur regularly and that they're not always harmful. As I've already noted, they're often beautiful. The northern lights are a stunning example of space weather generated by the solar wind. And some of the potentially nastiest events send their energetic particles and radiation in other directions and doesn't bother us. But we also know that space weather can have measurable effects, sometimes serious impacts, on critical infrastructure, systems, and technologies. They can disrupt a wide variety of systems, technologies and systems vital to satellite and airline operations, communications, navigation, and particularly the electric power grid. In 1989, as one example, a geomagnetic storm left 6 million people in Quebec without power for 9 hours. And on this very day, 12 years ago, the sun produced a powerful solar flare, just one of many in the great Halloween storms of 2003, and the associated geomagnetic event resulted in a power blackout in Malmö, Sweden. These Halloween storms disrupted other technology around the world, solar storms, including satellites, aviation, and a variety of GPS-dependent systems. And as technological systems become increasingly intertwined and interdependent, as more and more applications, for example, take advantage of GPS technologies, as power grids become smarter, as we move closer to an Internet of Things, the potential threats that space weather poses to our economic vitality, our national security, and our daily routines get more concerning. And that's why, under President Obama's administration, federal departments and agencies have worked to maintain and advance the nation's ability to forecast and to mitigate the potential impacts of space weather. Over the past couple years alone, we have taken steps to replace aging satellite assets essential to monitoring and forecasting space weather. We have introduced space weather standards in both the national and international airspace. We have pursued regulatory action to ensure continued operation of the electric grid during space weather events. We've explored a new option for replacing crucial extra high voltage transformers that could be damaged by space weather, and we have developed domestic sources for producing those transformers. In addition, the National Security Council, working across agencies and with industry, has been engaged in a major effort to ensure the security and the resilience, Senator Nelson, welcome, to ensure the stability and resilience of the electric grid to all kinds of threats and hazards, including space weather. Today, I'm very happy to announce that we're building on this progress with the release of a new national space weather strategy and a national space weather action plan. These documents articulate a path forward for the federal government in enhancing national preparedness for space weather. The strategy outlines the strategic goals that shape that path, including establishing benchmarks for space weather events, assessing vulnerability of critical infrastructure, improving forecasting and modeling of space weather events and associated impacts, enhancing our response and recovery capabilities, and coordinating internationally. The action plan, in turn, explains how the federal government will integrate and expand existing policy efforts to achieve these goals through concrete steps in both the near term and the long term. Both of these documents put a strong emphasis on the importance of cross-sectoral coordination, because space weather, as I emphasized before, is a cross-sectoral threat. Strong public-private partnerships must be established to enhance observing networks, conduct research, develop prediction models, and supply the services necessary to protect life and property and promote economic prosperity. The implementation of the space weather strategy and action plan is going to require the action of national and global networks of governments, agencies, emergency managers, academia, the media, the insurance industry, civil society organizations, and private firms. And indeed, a lot of these organizations are already stepping up to help. Today, a number of institutions are making new commitments to enhance space weather preparedness. For example, the U.S. Air Force, in partnership with NOAA, is making publicly available space environment data to validate and improve space weather forecasting. The Department of State is committing to hosting a series of workshops to increase international collaboration around space weather preparedness. And the American Association of State Highway and Transportation Officials, the National Emergency Management Association, and Airlines for America are all expanding their education, training, and outreach efforts relating to space weather. The breadth of these commitments underscores the importance of having multiple sectors engaged on this issue. And that's why it's so important that we have such a great diversity of representation in this room today. We have representatives from the many federal agencies and executive offices, including NOAA, NASA, USGS, NSF, DHS, FEMA, DOE, NSC, and more, which have been instrumental in supporting this administration's efforts to enhance national space weather preparedness, including the development of the strategy and the action plan. We have David Kane here representing the Department of Homeland Security for the state of Indiana, and others who bring their expertise and insight into what's needed at a subfederal scale to effectively support place-based preparedness. We have representatives from businesses and industries who can identify the most critical threats that space weather poses, and representatives from the academic sector who help us to understand the causes of these threats and what more we can do to be ready for them. We have Senator Bill Nelson and Representative Yvette Clarke representing the role that Congress must play to ensure that our government has the financial and legislative support that it needs to carry out the space weather strategy and action plan. And of course, we have the folks who are tuned in online to this event. That's perhaps the most important group. It's undoubtedly the biggest. And as I've observed before, since most people don't even know what the term space weather means, let alone why it's important to be prepared for it, it's good to have a big audience for this event. So I want to thank you all again for participating and for your contributions. I want to extend a special thanks to Bill Murtaugh, who is OSTP's Assistant Director for Space Weather and who played a crucial role in the development of the National Space Weather Strategy and Action Plan, and a crucial role in organizing today's event. So thank you, Bill. I trust and hope that today's event will go a long way toward raising awareness of space weather more widely and toward fostering the collaborative efforts that we need to address this challenge. And I now want to introduce Senator Bill Nelson. He was first elected to the Senate in the year 2000. He is the ranking member of the Commerce, Science, and Transportation Committee. He is also on the Armed Services Committee, the Finance Committee, and the Special Committee on Aging. That last one is of particular interest to me. Prior to serving in the Senate, he served in the House of Representatives from 79 to 91, and in the Florida State House of Representatives from 73 to 79. He served in the Army from 1965 to 71, and in my book, most remarkably, he trained as and served as a payload specialist on the Space Shuttle Columbia and was one of the 6 members of the mission STS-61C in January 1986, where he rode with the current NASA administrator, Charlie Bolden. So it's a great pleasure to turn the podium over to Senator Bill Nelson.
Thank you, Doctor. Good afternoon, and thank you, Doctor. And OSTP, the Office of Science and Technology Policy, is really run by a scientist. And I always am amazed at some of our colleagues. They say, they're asked a question about scientific matters, and they say, I'm not a scientist. But the fact is that you can get to know scientists, and the privilege is mine to get to know Dr. Holdren. Thank you for gathering on a topic that is very narrow in focus, but is extremely important. And we've come a long way in the last several decades to understand this thing called space weather, but the potentially severe impacts to our terrestrial life, be it utilities, communications, transportation systems. What people don't understand as they are using these tablets, and it is operating off of the GPS system of satellites. All of this makes space weather events a threat that we need to better understand and to prepare for. And then as we seek to send humans into space further and further, and we're going to Mars in the decade of the 2030s, I commend to you the Matt Damon movie, The Martian. It is more science fact than science fiction. As a matter of fact, the author of the book collaborated with another one of our crewmates from the 24th flight of the space shuttle, Dr. Franklin Chang Diaz, who for years has been building a plasma rocket that will take us much faster to Mars. And the technology in the book for the vehicle that gets them to and from Mars is actually the propulsion technology of Dr. Chang Diaz. So the solar flares pose a real threat to radio communications used by pilots traversing the poles, and to military and commercial satellite communications. Indeed, all of these impacts need to be better understood, and the solar events causing them need to be better predicted and mitigated. And oh, by the way, it's not just those man-made objects that it will affect us. If we're flying in the wrong place at the wrong time when there is a solar explosion and that radiation is coming our way. Now, to better understand this phenomenon, we launched the satellite Discovery. Discovery has had a tortuous path. And by the laughter and the smiles, some of you know that tortuous path. It started out as a favorite of Vice President Al Gore called Triana. And Triana was going to be at the Lagrange point between the Earth and the Sun that's neutrally buoyant, where the Earth's gravitational pull stops and the Sun starts. And that's approximately 1 million miles from Earth, 93 million miles from the Sun. And Triana was going to look back at Earth and give us as much as can be possible with the transmission delay, real-time pictures of the Earth. But the next administration, particularly the vice president who succeeded Al Gore, did not like that. And so he got the mission canceled. The good news is that NASA saved the vehicle, the satellite, the spacecraft, and they put it on ice. And then years later, along comes us then able to reactivate this. Yours truly had a hand in it, of piecing together many instruments, and there are primarily 4. But one of the original purposes of Triana was preserved so that you can go on the NASA website now and you can get a fairly near real-time picture of the Earth every hour and a half, 365 days a year, as the Earth is revolving around its axis, since Discover is on the daylight side of the Earth looking back. But there's an instrument on the other side that's looking the other way, and it's looking at the Sun. And that is the early warning, so to monitor the solar winds and improve the accuracy of the space weather alerts and forecast. Yesterday, NOAA took over the operations of the satellite and has begun optimizing the final space weather instrument settings. NASA is planning later on an exciting mission called the Solar Probe Plus that will send a spacecraft closer to the Sun than ever before. And hopefully it will not be like Icarus, who got too close to the sun and burned up. Solar Probe Plus will touch the sun for the first time, sampling the atmosphere at up to 2,500 degrees Fahrenheit. And funding this groundbreaking research, it comes from NASA, from NOAA, and the National Science Foundation. And let me give credit where credit is due to the Air Force, because we got the $150 million launch from the Air Force because of the obvious national security implications of getting these early warnings. The work of scientists and engineers at these agencies will help us better predict solar events, and therefore it's going to help us better protect the infrastructure of the U.S. Now, I'm very happy that the sworn interagency working group has nearly completed its work on the National Space Weather Strategy. And as the administration finalizes this strategy, Congress will play a significant role in funding the research needed to better understand the impact of the solar emissions. As Dr. Holden said, I do have the privilege of having some finger stuck into this jurisdiction, and I look forward to working with the experts at NOAA and NASA and the other agencies to continue to educate our policymakers and the public about space weather. You know, you think about sending humans as far as Mars. If there is a space weather event, they will be fried with radiation. So in the design and the development of these technologies, we have to still do this. We not only have to get there faster, because right now with conventional technology, it'd take us 8 to 10 months. By the time you got there and landed, the planets would be out of realignment. You'd have to wait a year on the surface to then come back. With faster propulsion, we can stay there for a much shorter time. But that doesn't solve the problem of how do you protect against the radiation for the human body. Indeed, we have humans up 6 right now on the International Space Station. They have a place in the station that they can retreat to, but we have to give them warning so they won't get the excessive radiation. So all of this is part of the challenge, and thank goodness we've got Discover. Thank goodness we're doing these new probes. Thank goodness that you all are here today to focus on this subject. I thank you. Have a great day and a great conference.
All right, thank you, Senator Nelson, for those words and for all your help and assistance, especially on the space-related activities on the Hill. We'll now move on to the next phase of our program. For those who don't know me, I'm Bill Murta. I am the Assistant Director for Space Weather here at OSTP. Some of you know me from when I wear my NOAA hat. I am now 13 months into my 6-month detail, so got that timing off a little bit. But very glad to be still working here. So the Swarm Task Force brought together a unique combination of agencies responsible for the security and reliability of critical infrastructure, for emergency preparedness, and for space weather science and research, all joined by a common bond to identify near and long-term national protection priorities with respect to space weather. We'll begin this next session on space weather preparedness with some words from one of the people who lead the national effort to protect and enhance the resilience of the nation's critical infrastructure. I'm very pleased to have the opportunity to introduce Suzanne Spalding. Suzanne serves as the Under Secretary for the National Protection and Programs Directorate, the NPPD, at the Department of Homeland Security. She oversees the coordinated operational and policy functions of NPPD's subcomponents, which include Office of Cybersecurity and Communications, and the one that we work very close with, the Infrastructure Protection. Suzanne oversees NPPD's mission to strengthen the security and resilience of the nation's critical infrastructure. I'm very excited to introduce Suzanne. Thank you.
Bill, thank you very much, and thank you for your leadership and all the great work that you've done on getting this strategy where it is today and helping our team. It's been a real honor for the Department of Homeland Security to co-chair this effort to produce this National Space Weather Strategy along with our colleagues here at the White House and at the National Weather Service. But we're also very grateful to so many of you in this room and others who were a part of that process. Our federal, all of our partners from the various federal agencies, certainly from state and local, territorial and tribal, and I'm pleased to see that we've got somebody from the states here today. Our private sector representatives who are such important partners, our partners from academia and NGOs and members of the public. Who engaged on this issue with us and provided important insights. As all of you know, ensuring the security and the resilience of our nation's critical infrastructure is not solely, and really not even primarily, a government, something that the government alone can do. It's a national challenge. And so I am particularly grateful for the insights and the input from our private sector colleagues. Supporting the development of this strategy has been an important priority for the Department of Homeland Security. We believe it will help enhance our common understanding of this unique risk and increase the nation's security and resilience. The Department of Homeland Security is at heart in the business of managing risk, particularly at the National Protection and Programs Directorate. The foundation of the work we do is all about enhancing risk management. Meaning it's the responsibility to address the possibility that bad things might happen. The nation faces a great many risks, and understanding the likelihood and consequences of those risks is inherently complex and challenging. DHS takes an all-hazards approach to understanding and managing that risk. And that means we must develop a broad set of capabilities that will address a broad set of risks. But we also understand that certain risks like space weather, present a unique security and resilience challenge to DHS and to the whole community. Efforts like this national strategy help us improve our understanding of these particular risks, and more importantly, help us improve our national response to these risks. Having said that, it's important to note that this strategy is not intended to represent a divergence from our all-hazards approach, nor to create a competitor system to handle a specific kind of risk. Rather, this strategy supports directly both the National Preparedness System and the National Infrastructure Protection Plan. The National Preparedness System, as all of you know, provides an important, holistic, all-hazards approach to preparedness. And our goal with this strategy is to identify areas of improvement in that current system and ensure that they get the attention that they need. You'll see in this strategy that the focus areas span protection, mitigation, response, and recovery efforts, and really help ensure that the National Preparedness System is well situated to cover a space weather event. The work conducted in support of the strategy will augment the national preparedness goal, planning frameworks, and the interagency operational plans, which are now undergoing revision, as you know, as part of the PPD-8 update. The partnership structures established under the National Infrastructure Protection Plan, the NIP, also will be instrumental in meeting the objectives of this strategy. It will be through that NIP structure that we're able to partner with the private sector and collaborate in understanding impacts and planning for response. Perhaps most importantly, the National Space Weather Strategy offers a platform for continuing to better understand the phenomenon of space weather. In our modern era, we have not had a major event of this type, and the strategy recognizes that new knowledge is required to help us understand and prepare for the risk. As you're aware, and has been discussed, different space weather phenomena have different potential to impact a wide range of infrastructure systems, including communications, aviation, and energy infrastructure. Recognizing that much needs to be done, I want to emphasize, as Dr. Holdren did, that we have accomplished much to improve the grid's resilience to this and other threats. The majority of the nation's critical infrastructure, as you all know, is not owned or operated by the federal government, but by private industry. The foundation of DHS's critical infrastructure mission is robust voluntary public-private partnerships, where the federal government works in support of owners and operators to manage the risks that could disrupt their businesses and impact the continuity of critical services and functions. Over the past 12 years, we've worked to build a strong partnership with owners and operators, recognizing that disruptions and attacks on infrastructure impact homeland security, community resilience, and the economy. The industry takes its responsibility to provide these critical life services that are essential to life, health, and safety of customers and communities very seriously. And the partnerships we have built support the continuity of these services. We know we cannot provide 100% protection for every asset, network, and system from every threat. The electric sector, for example, follows a multi-layered risk management approach to grid protection, including protecting the most critical grid components against likely threats, building redundancy into the system to make it more resilient, coordinating preparation and response efforts with the government, and developing contingency plans for response and recovery from incidents that are both man-made and natural that might impact grid operations. We in the federal government, along with our partners at DOE, at FERC, and elsewhere, help these efforts by deploying tools and technology to improve industry and government situational awareness, improving access to security threat information for all grid operators, and conducting outreach in response to threats against the electric sector and promulgating protective measures and mitigations. The grid is extraordinarily complex, and by that very nature, it is more resilient than many in the American public give it credit for. While deterrence, detection, prevention, and protection are all hallmarks of security, the biodiversity, if you will, of the grid makes a widespread attack more difficult to perpetrate. The electric power sector also relies on its ability to respond and recover when considering its security posture. As we've heard today, a major space weather event could have significant impacts, and we need to better understand how and where those impacts could occur, and then leverage our mutual comparative advantages to address them. The 2015 Strategic National Risk Assessment provides quantitative and qualitative assessments of the frequency and impacts of threats and hazards, along with the risks they pose to the nation. And it's a foundation for understanding the risk. However, the articulation of space weather risk in the Strategic National Risk Assessment is just the start of the work that is laid out ahead of us. Preparing for space weather events requires joint actions from public and private stakeholders, and their shared expertise and responsibilities are embedded in this strategic goals. Those preparations work to reduce vulnerability, minimize risks, address cascading effects, and enhance disaster resilience. This strategy articulates 6 overarching goals. First, establish a benchmark for space weather events. Second, enhance those response and recovery capabilities. Third, improve protection and mitigation efforts. Fourth, improve assessment, modeling, and prediction of impacts on critical infrastructure. Fifth, improve space weather services through advanced understanding and forecasting. And sixth, increase international cooperation. These goals are structured to be mutually supportive. So, for example, when we improve our understanding and observation capability of the various types of space weather, along with our ability to benchmark space weather risks and remedies, it improves our ability to take informed action and to work collaboratively to reduce risk in infrastructure systems. Increasingly, the security and resilience of infrastructure against space weather risks requires strong public-private partnerships. We are working with our partners to achieve long-term vulnerability reductions in those risks from space weather events by implementing new measures at locations that are most susceptible to space weather risks. In conclusion, let me just emphasize again that this national strategy is an important step in building our national preparedness capability for space weather risks. The efforts undertaken to achieve the objectives of this strategy will establish a national approach to the security and resilience in the face of our improved understanding of the seriousness of the space weather risk and the steps we must take to prepare for it. I want to thank again everyone in this room who has worked so hard to get us to this point. And I want to take a particular moment to thank my Assistant Secretary, Caitlin Durkovich, our Assistant Secretary for Infrastructure Protection, who really led NPPD's efforts on this, and who is now going to moderate what I anticipate will be a very enlightening panel. So thank you very much, and thanks again for all your work.